Hello everyone, it's Miss Redmond here. Welcome to your second lesson in the light topic. This one is called What is Reflection? You've got your success criteria down here. So if you haven't got one already, go and get yourself a pen and a piece of paper so that you can write down notes like the success criteria and do any tasks that I give you as we go along. Alright, here's a little challenge for you. List as many surfaces as you can where you can see a reflection. So give yourself a 1-minute timer and write down all of your ideas. Then if you want to check them, you can send them in to your science teacher. There are two types of reflection and they're called specular reflection and diffuse scattering. Specular reflection is a reflection from a smooth surface where you can see an image, and that's what's being shown in this diagram. So all of the rays that come in together reflect off together. So they stay together, and that means that we can see an image in this surface. So this could be a surface like a mirror or a shiny window, or maybe your computer screen or your phone screen that you're looking at now. And then diffuse scattering is a reflection from a rough surface, but you can't see an image. So you can see objects because light is reflecting off them. But the thing is, most of those objects, the surface is very rough, like in this diagram. So when the light comes in to hit that object, it bounces off, it reflects in lots of different directions. So it doesn't stay together like the top image, the top picture where we see an image. It bounces off in all directions, so we can't see an image on this surface, but we can see the surface itself because light's reflecting off it. Okay, I suggest you pause the PowerPoint and write those notes down. So ray diagrams, this is how we draw a ray diagram in science. So we've massively simplified what's going on. The symbol for the mirror is here. So it's a straight line with a ruler and we've got diagonal lines behind it. That's showing us a mirror. The incident ray is the ray that's coming in to hit the surface. Again, that's drawn with a straight line with a ruler and a pencil, and we've got an arrow to show the direction. Now, where that ray hits the mirror, we draw what's called a normal, which is an imaginary line at 90 degrees, sorry about the background noise, to the surface of the mirror, and that lets us measure this angle here, which we call the angle of incidence. Makes sense because it's the angle of the incident ray. When the ray hits the mirror, it reflects off, and this is now called the reflected ray. Again, we've got an arrow to show the direction it's going in, and we can measure the angle of that ray to the normal as well, and we get that angle of reflection. So pause the PowerPoint and write down those notes in the diagram. Okay, here's a different ray diagram. It's a challenge if you want it to copy and complete this diagram. So we've got a plain mirror in the middle. We should really have our diagonal lines behind it to show it's a mirror. We've got a light source on the left, and we should also have arrows showing the direction of the rays. And the rays of light are travelling towards the mirror, they're bouncing off, they're reflecting, and they're being absorbed by this person's eyes. The question is, where will this person see the image of the candle in the mirror? So copy and complete that, and I'll show you the other side in a second. So the brain is very clever, and it's learnt from experience that light travels in a straight line. So it follows these rays back to the point where they meet, and it sees the image of the candle here in the mirror. So that's what your completed diagram should look like. Another challenge, a student is writing about light. Can you spot their mistakes? So I'll read this out to you, and then you can pause it and make a note of any mistakes, and preferably how you would correct them. Light is a longitudinal wave. It does not need any particles to travel, so it can't travel through a vacuum. When light hits an object, it refracts. There are two types of reflection, diffuse reflection and specular scattering. A book is an example of specular reflection because you can see an image in it. A piece of paper is an example of diffuse scattering because although you can't see the paper, you can see a reflected image in it. The image in a mirror is called a visual image because it's not really there. Right, have a think about where the mistakes are and I'll reveal the answers on the next slide. So the first one is light is not a longitudinal wave, it is transverse. And it doesn't need any particles to travel, so it can travel through a vacuum. Okay, when light hits an object, it doesn't refract, it reflects. There are two types of reflection, that's true, but they're not diffuse reflection and specular scattering. They are specular reflection and diffuse scattering. A book is an example of specular reflection. No, it isn't. A mirror is an example of specular reflection. You could have other options in there because you can see an image in it. A piece of paper is an example of diffuse scattering. Yes, it is, because although you can't see the paper, really, you can see the paper, you can see a reflected image in it. Nope, you can't see a reflected image in it. The image in a mirror is called a virtual image, not a visual image, because it isn't really there. So well done if you got those right. And those are all the answers. Feel free to pause the PowerPoint and copy that down. Here's your summary. An image is a visual representation of something. Virtual image is one that is not really there, like a reflection in a mirror. A plane mirror is a flat mirror. Normal is an imaginary line drawn at right angles to a surface, in this case a mirror. We'll talk more about normals next lesson. An incident ray is the light ray which hits the surface. The angle of incidence is the angle between that ray and the normal. Reflected ray is the ray which bounces off a surface, and the angle of reflection is the angle between the reflected ray and the normal. Thank you very much for listening. I will speak to you next time.